possible. So we're just kind of going through a couple of procedures in the manual here to maximize the light intensity. So that's done. And so now we're going to basically make sure the light is kind of going as good as we can down straight from the source to the receiver without the sample blocking in. So the sample is out of the way. So basically we want to do that same setting that I just did, but I'm going to set it to 1500 nanometers instead of 300. So we're going to kind of go to it. We're going to monitor this at a different wavelength for this. So pretty much, again, just following the manual. So we're going to say monitor xenon lamp intensity, and instead of the default 300 on that setting, we're going to go to 1500, stay at 90 degrees. So here, so it's moving. The monochrometer's moving. It's 1500 nanometer light instead of 300. It's asked me to shim the stage back. It's already shimmed. But the stage is shimmed back. So we're just again following the manual. So we're going to max. So in this case, we're not. In this case, like the manual says, we're just basically. I showed how to put the fiber on earlier. We're basically just going to do the adjustments on the fiber. This will either be an 1/8 or 1/3 millimeter wrench will work for this. So for this other thing, we're gonna again. So this you guys aren't doing on a daily basis or anything. This is just the initial kind of setup. Essentially, we've got the optical fiber on there now, and ready to roll. Just gonna kind of let that sit here. This fiber is coming in through. Basically, it's getting there's a collimating lens there to take that fiber that we spread it out and shoot it down. So currently, the light's going to come straight from the source to the receiver, and we're just monitoring this at a different wavelength. And so, in general, what we're doing is this is on a tilt stage as well. Basically, I'm just going to adjust the two corner tilts here. So this guy and this guy to try to minimize this M1 value. Okay. So it's already very, very small. It's like 0.0019. Okay. This one in the middle here, I'm not going to adjust because this is basically a tilt stage. And so if I adjust this, think of that as your pivot point. So if I adjust that, that's going to go this way or this way. If I adjust these two, if I adjusted all three, that tilt stage would kind of move in and out. So that's the middle adjustment's already kind of been set at the factory for this system. Okay.
Maybe we should put a note or something.
Yeah. So sometimes sometimes people put
for, yes.
This is for this. Every time you change the fiber, essentially.
Every time you change fiber.
But to be fair, I was telling Zach. So that's probably one other difference. So this fiber, and you have the DUV system that goes way down in 193 nanometers. For the spectral range of this tool, go to 2500 nanometers. You can just leave this fiber on. There's one other fiber we ship that we use for systems that go further in the IR. For the most part, I think you guys can always leave this fiber on. The other fiber. Some are about 2.3, 2.2 microns, so 22 might have a little bit more throughput than this one. I mean, they start crossing, essentially. So those last couple hundred nanometers at the farthest IR, that one might have a little more throughput, but it's not going to transmit in the UV. So it's kind of you can use this one, it just might be
more like a general purpose.
This one worked, but back at Missouri, when you had if you had the UV fiber on, you would have had a gap around 1300 nanometers. This particular fiber doesn't have that gap, so that's nice. So here, essentially, I'm going to check this adjustment here and this one down here and try to minimize M1. But I'm going to kind of do it while I can see the screen as well. So don't worry about the signal right now. We're just trying to minimize this M1 value.
Oh.
So just a little bit of adjustment to see if that goes down any bit. It's already quite small, but.
Okay. And this one, right?
Yeah.
So does it matter that in the dark environment
Not for standard measurements because we have a chopper. There's a chopper in the monochrometer. So basically we're locking onto the chopper frequency. So no. Lights on.
Oh, I'm sorry.
You want this one to go down.
Oh, I was looking at that. Okay, I was looking at the wrong thing.
Okay. So I was wondering, yeah. So
Yeah.
we want to minimize this. So it's a little bit deceiving.
Yeah.
Theoretically, actually, hopefully this is stays near maximum when this is minimum.
Mm-hmm.
But this particular part of the procedure, we're trying to make
Right.
we're trying to have that steer straight down the optic axis. And
Mhm.
our best indicator of that is how low this value is.
Right.
Yeah, if everything's perfect, sure, your signal's still great, but that's, you know, you can always sacrifice a little signal to try to get this as low as possible.
Yeah, I think that's great.
Maybe. I saw we're pretty low. We'll go a
We
little
had
bit lower to start with.
021, right?
Yeah, I've
That
seen
was-
001 once. I was
Oh,
just
yeah.
trying, yeah. 0019, it wasn't very much lower. Um, I think when you were closer to, I mean, theoretically, it should still be near max signal when that happens, but they're not always exactly the same. So I'm just kind of doing a small step. I think the other trick would be to make sure we're not touching the fiber, touching that. So 002. So I'm kind of doing a small step, let go, small step, let go. Again, we're kind of splitting hairs here. It's harder to get it much lower if we're at a limit. But I'm gonna try. So it's hovering around 001 or right below it. So let's try that for now. But if essentially if somebody pulls the fiber off and puts it back on, it's best to check that because it's kind of the most direct measurement we have of it. Okay. So essentially we want to make sure we got the throughput we could from the lamp with the first setting. Again, you can check that occasionally, but again, that's we've done most of what we can. And then the second part of this was just to minimize M1. Okay. So now essentially we're going to go ahead and calibrate the tool. So here, this instrument has, again, it's a vertically mounted system. So your sample is going to mount here vertically. This vacuum pump is currently on. That little orange pump back there is a little vacuum pump to hold the sample here. This switch here closes it or opens it. So normally, if you don't have a sample on there, you want this closed. You basically don't want to be pulling vacuum through it. You hear this when you walk in. It's either because you don't have a sample there, but the vacuum's on, or you've got kind of a piece of paper, something that's leaking a little bit. In general, if you hear that and no sample is there, I would just leave it off. Sometimes people leave it on in their lap if they don't hear it or whatever. You're just kind of pulling air through the pump, so that probably reduces the lifetime of that pump a little bit.
But otherwise, the pump is okay to be on all the time?
Yes.
As long as.
Yes, as long as this is closed, you can leave the pump on.
Oh.
Yeah, there is a switch on it, but you don't have to turn it on. Normally, this is a situation that's usually it's just unless one particular person's in there, because they always for some reason leave it on. But in general, just close this when you're not using it. That's good to go. Because what you don't want is if someone turns off the pump and you think you have vacuum, they're like, oh, I dropped my sample because and then there it shatters. We left this in for a second because we were shimmying the stage back. Okay, I'm gonna push this back a little bit and pull this out. This was just a temporary. This is also for mounting like a heavy sample, essentially. So this is a support if you had a heavy sample. This is also you can also move that if you want to center something too. But it's that's an easy shim for me. Whereas I need to find something else for it. So what we're going to do here is we're going to mount a wafer here and we're going to align it and we're going to calibrate the tool. So this will be more of this initial part will be what you do for every sample you do in alignment. The calibration that we do, probably do relatively often. Every time you restart the software, you'll have to do it because when it initializes one of the motors, it's kind of a random position where it goes to, so it needs to recalibrate. Okay. If you leave the software on after it's been calibrated, theoretically you don't have to calibrate again, but that over time that can drift a little. So I normally for a VASE, again, so it's a slow instrument anyways. I normally calibrate every day. Some people don't calibrate until they really need to, but it doesn't hurt to calibrate once a day just to make sure. Okay. But that's the other.
Day is okay. Like as long as you're not don't have to do any for every measurement.
No, once a day is fine. It's just if you restart the software and it reinitializes, you'll have to calibrate. So if for some reason you don't want to have to again, like say you're going to start another measurement tomorrow morning and you're like, oh, it's good, leave the software running regardless. You can turn off lamp, but leave the software on. Okay. So this initial part that we're going to talk about here is just for a standard sample alignment. We're just going to do it with calibration. So again, this will be pretty much done for any for the calibration or any standard sample alignment. Okay.
again, vacuum is at least ready to roll. This stage here has, you can kind of see where the beam's going to be, kind of the center of this stage. There's no mapping on this particular one. So essentially, this stage has two zones for the vacuum. So a large sample and a small sample. So the small sample, so if this is in the down position, this little switch here, that toggles between the two zones. So if this is in the down position, that's the small sample position. It's just going to be kind of these two little, there's two little holes with like circles right here. So that's for if you had a small piece or your 1 inch wafer. This, well, you'd have to use this. The large one is these two slots. So you could use either for this wafer, and that will be enough vacuum to hold it, but that's the main difference. So just make sure you're kind of on the right zone, okay? Just that's where the sample is going to be pulling. If you have a really small sample, that's what this stage is for. Essentially, you can take this plate off and these screws here, put this on, essentially, and then you have a little spot here that holds vacuum, and put your tiny sample on this little guy. So that's for small samples. Okay. So this kind of rotates.
Gotcha.
Yeah. So that just pulls vacuum through basically a little hole. Okay. That's small. Again, if you had something heavy, this can be used to slide up and down, or you can also mount. If you like, say, always putting a big optic on there, that's always the same. You can screw this in here and then slide it to support. This is like a shelf support because, again, the wonders of mounting vertically. So normally what I do, again, you can have your tweezers or whatever to hold it. That's for the cal wafer. What I usually do. So these are single side polished wafers. Okay, but this stage is designed such that you see there's a kind of an edge here, so I can actually hold it against that. And so I'm not. You can use wafers if you want, but normally what I do is I basically turn the vacuum on. Again, we could really use either zone for this. I'll go over the big one for now, just for fun. And I kind of just go like this, and I wait till I hear vacuum wasn't there. Now, if it didn't pull, I can give it a little bit of a, just to go back. Similarly, again, I'll leave you guys a spare wafer. It's in my bag. But in general, you could use tweezers, but you kind of really want to hear for the vacuum to go away. When the vacuum was on, when it goes away, that means you have suction, right? Okay.
Now, this is what we used to do in the
Yeah.
circuit.
Just kind of, if you have a big enough wafer, that's always easier. So good deal. So now we're going to kind of go through the alignment and this, how we calibrate for this guy. So we're going to go again in VASE here. We can cancel out of this. Again, I've lost some signal now here because again, I moved this forward and I'm blocking part of the beam. So I didn't realize that was still on. So we'll just escape out of that guy. Okay. So again, in the hardware tab, hopefully everyone can see. Is that good enough? Okay. So in the hardware tab, we're going to say acquire data, align sample. Okay. And now it's going to ask you, so if you didn't leave this in, so again, you can leave it in if you want a smaller beam, but again, your compromise is you have like an eighth, seventh or an eighth or so, you lose quite a bit of light. So it's a signal to noise thing. But basically what this is so we can properly get the tip tilt alignment of the sample. Okay. So what this is it's got a guide pin on the top there. I don't know if you can see that. Okay, and it's got these connection pins for electrical. So the main thing is you don't want to accidentally break a pin. We have replacement kits for them, all that fun stuff, because it can happen. But that guide pin goes to the top. So and it's going to basically, there's a hole here. We're just going to kind of go in. So normally what I do is I had the pin close to the top. We're going to have this close to the top under the hole. Okay, I kind of wait to see where it's easy, because it doesn't want to go back until that guide pin goes, and it'll go back another, say, 2 or 3 millimeters. You see that? And then I can push it till it snaps. But if you don't have that easy part where it's sliding at a couple millimeters by itself, that's the guide pin, and let the snap. So again, you can leave it in during your measurements. I'm going to take it out during the calibration just because that's normal for this procedure. Okay, and then usually what I do is I leave it here, or some people put a little, or leave it in the tube or whatever you want. Okay, so we insert the alignment detector like it asked us to. Now what's going to happen is, for a sample alignment for the ellipsometer, I need to have both the tip. So we're going to be reflecting light off the sample at an angle. So the reflected light is going to depend on both how tall that sample is. So in this case, was the sample, did it hit sample here, or did it hit the sample here? That's going to steer where the beam is. And that reflected beam is going to be the tilt of the sample. So we need both the tilt of the sample and the height aligned to the system. Okay, when you put a new sample, how thick is it? Is it tilted? Is it a wedge? Those types of things. This initial step is going to get the tip tilt out. So what happens is, when I say okay, it's going to rotate the sample back to normal incidence. So, and it's going to shine light at the sample and then bounce it right back onto itself. So that unit there, that barrel, has a 4-quadrant detector. So basically 4 detector zones, 4 quadrants, with a hole in the middle. So the light goes out through that middle hole, bounces off the sample. It's collimated, but there's a very, very slight divergence. So it gets a little bit bigger when it comes back. And what bounces back onto itself is seeing those 4 quadrants. So what we see here is those 4 quadrants. So essentially, how much light is on each of these. So if I want to get this flat with respect to the ellipsometer, I'm going to tilt this until the light bounces. The light I shined in comes right back onto itself. So that's what we're going to center here. Okay, and we do this at normal incidence because theoretically this should not depend on how thick your sample is, right? My sample could be 5 inches back, and I can still align the tilt, right? So it decouples the height from the tip tilt. So this system's got 2 knobs for tip tilt. That's here and here. Okay. So basically, we're just going to center this. So I'm going to turn this a little bit. We're just going to get this centered up, as long as I go the right way. And you'll see, so you have some gray bars there on each quadrant. That's kind of like how much light is on each quad. And you might lose a little bit of signal as you center it because, again, this is going through a hole. So I'm losing some of the light through the hole. So the main importance here is to center the crosshair, not the absolute signal. Okay. So, and within a few units is fine. Again, I'm nervous that I'm on camera, so I'm not thinking of it. But you see what I do is, rather than have my hand on there and possibly influencing it, I turn it a little bit, let go. I turn it a little bit, let go. Because the other thing that happens, so let me turn it one time. 1, 2. See the double step? So it's got to update all 4 quadrants. And so if you're trying to be speedy, Mr. Speedy on there and going real fast, well, you're kind of hurting yourself. So, and again, it's a bit overkill. And so you have both the visual position here and then your XY position of that. Okay. So you want to get it within a couple units is fine. Since I'm getting recorded, I'm going to see how close I can get. But you don't have to be perfect here, okay? I mean, that's plenty, okay? Make sense?
Yeah.
So essentially that gets the tip tilt of your sample out there. If your sample was not as flat, or not, we're going to flatten it out by doing this process, okay? So when I hit escape now, essentially it's going to go to the next step of the process, which is the height alignment. So that's me getting picky. Okay. So when I hit escape, it's going to go ahead and go do the height alignment of the sample, which means by default it's going to, I think, move to 70 degrees. So again, since it's a theta to theta goniometer system, we're measuring that angle from the sample normal. So here to here is 70, here to here is 70. So this stage, if you look at the goniometer, should be at 70. The receiver unit should be 2 theta, should be 140, 70, 240, okay, in this case. Now it's going to give you a message. So basically it's going to shine the light, reflect it off, and go into the detector. We know that it's flat, but we're going to maximize the signal by translating the height. So if you had a thicker sample or thinner sample, we're going to get the height corrected by this micrometer. Okay. This is where, if you leave this in all the time, if you're going to leave this in for measurement, leave it in for this step. I'm going to actually calibrate, so I'm going to pull this out for this. Okay, that's kind of the normal procedure. And say okay. And what it's going to do, it's going to bring up a screen here, kind of similar to what we saw a little bit ago. And so now we're just going to move this back and forth. So it looked like it was already really close because I've gone both ways and I was already at a max. Okay. Okay. So we did tip tilt, and we did the height. That's going to be done for every sample. If you guys leave this in to have a smaller beam, leave it in for your alignment, your sample alignment too. You just want to be consistent. Okay. So hit escape. So now I'm going to go ahead and calibrate the system, and I'll tell you what it's doing as we do it. So because it says we're initialized, but we're not calibrated. If you restart the software, it actually will still say that because, again, we've got to figure out where all those motors are and everything. So when we do a calibration, again, the manual will talk you through this too. We're going to go to that same acquire data, and then we're going to go ahead. So we've already aligned the sample, and we're just going to go to calibrate system. Okay. So when I say calibrate system, by default, yes, with this system, you can pretty much just keep it at the defaults because you don't, just keep it at the defaults. Keep it simple. Right now, we can just do a fine calibration. If for some reason that fails, we'll do a coarse and then a fine. But hopefully just leave it on the defaults and say okay. The main thing is to make sure that this wafer is there. We want to calibrate off of a easy, nice reflective sample. Okay. So what's happening here? Again, this system sets up a plane of incidence. The plane of incidence is going to contain the source beam, the reflected beam, and the sample normal. So in this case, I'm not going to block the beam, but your plane is in this orientation here. So we've got this plane of incidence, okay? And we're going to be measuring how polarized light reflects off that sample. Well, we're going to say how does P polarized light reflect and how does S polarized light reflect? And we're doing a ratio of that per wavelength, per angle, whatever we're doing, right? So we need to know, we've got optics in here, polarizers, analyzers, that retarder, auto retarder unit. We need to know, well, where is the polarizer right now? Is it 20 degrees with respect to that plane of incidence, or is it 30.2? So the main thing this calibration is doing is figuring out where all the optics are. Okay, and especially this system has on the receiver side, the polarizer on the receiver side is called an analyzer. This system is a rotating analyzer ellipsometer, so that analyzer is constantly spinning. So it needs to know where is that analyzer at all times. Okay, so that's the main thing, that when you restart the system, that can be a random starting position. Okay, but once it's up and initialized, it knows it. So this will take a minute or so. It's like 40%, maybe a couple minutes. And then once that's which one?
You said we had a coarse and fine.
Calibration. So yes, by default, let's hope that passes. Essentially, that's just the main thing there is how much. So let's say that this was my plane of incidence, and I figure out where stuff is. Well, if I do a fine one, it means I kind of already knew where the polarizer stuff is, so it's going to kind of do a search here. If I do a coarse, it's going to look over a much wider range. Just takes longer. So if for some reason, we lose a lot of, I think we're okay to just do a fine. If it fails, I'm going to start with a coarse because it's initial setup. But by default, you can just do a fine. The main issue would be is if something really got rotated weird. Okay, so coarse is just a wider search, really. But by default, hopefully the fine works out here. But we haven't tried it yet, so we'll see how it goes.